A little more on graphics from our last lecture. PDFs are an important file concept for us to understand, especially for technical drawings. PDF was actually created not to create technical drawings, but to share artwork created in things like Adobe Illustrator and Adobe Photoshop. Early on, Adobe was really good at creating high quality fonts, and there needed to be a way of sharing that kind of information in early computers. And they created a format that would allow people to share things on a common piece of software platform that would allow it to open up and look exactly like it did on your computer as it did on someone else's. And that almost seems kind of archaic today because we take PDFs so much for granted. So these are hyperlinked, a little more explanation of it. PDFs are really rich in the amount of capabilities they have. If you actually would go to one of your PDF files where you've cut a section through a building, if you click on the marker in the PDF file of that section, you'll notice that it's hyperlinked. It'll actually take you right to that detail section inside of the PDF. So a lot of things are happening in the background with PDFs that make them really rich and useful for us for our technical drawings. And they weren't available to us a few years ago because it required owning or purchasing the Adobe Illustrator software for making PDFs. But in 2021, maybe 2022, Autodesk included a PDF exporter of their own, so we were no longer required to own an Adobe product. And that opened up a whole lot of opportunity for us to share our digital PDF files with other people. And so now today we have a full assortment of page sizes, of technical drawing sizes that we can export in that rich high resolution PDF output. And conversely, we can import PDFs into our software. So we can take rich, what I'll describe more in detail as the vector-based drawing, accurate CAD type drawings, two-dimensional though, into our software and use those as base layers for laying things out. Like somebody might provide a site survey that has important information in 2D, and we can then place our building on it and then locate things like trees or whatever very accurately because our PDF file is vector-based. So if you're confused about this idea of vector and raster graphics, bitmapped ideas, I hope this will kind of clear things up a little bit for you. So here we have a soda bottle graphic. Looking at it on the screen, we don't know if it's vector or raster based. The only way we can really tell that is to zoom in. And if we do, if it is vector based, it'll stay very sharp because everything is defined as a vector, a line. So a line has a start point and end point. In this case, it's a set of lines to make a rectangle. I'm rolling over the eye. I've got to get on the right screen here. I'm rolling over the eye. And we can see now it's a rectangle filled with black. It could be a rectangle filled with white, but it's very sharp. No matter how close in we get, it'll always be that sharp. But the same graphic, if it was exported as a bitmapped or a raster graphics, as we zoom in, we'll find that it has made determinations about the amount of resolution. It's a finite amount of resolution. And so we get this kind of what's called pixelization of the image or bitmapping of the image. And it's important for us to have this distinction with the way we share data with each other and import data. For instance, if we're provided a map and it's vector-based and we zoom in, we'll have really sharp details at the close points of it. But if it's raster-based, as we zoom in, we'll have very limited amounts of information. And so this can be really important for us in transferring accurately our dimensions and our data from things that are provided for us. So if you're asking a client which way to provide a drawing or a site plan, you'd always want to ask it to be, if at all possible, as vector-based graphics. And our software, our illustrative software, Photoshop and Adobe Illustrator, kind of significantly differ from each other in that concept also. Photoshop is a piece of bitmap software. It takes, if we were to make a letter with it, like a letter O, it would create it into a bitmap or what's called a rasterized image. It can look very sharp, but if you zoom in on it, you'll see this kind of pixelation happening. If you made the same letter in Adobe Illustrator and you zoomed in on it, it would stay very crisp on all of its features. And the demonstration of that in CAD drawings is this is the front of the building we've already gone through and dimensioned. And this is the comparison of a raster output, a JPEG file that I've created, and a vector output on a PDF file that I've created of the same area. And so when we zoom in, you can see this idea of pixelation, especially around the 0. Look at the diagonal line that is the tick mark on the end of the dimensioning, and how it's pixelated. And so it would be very difficult to get accurate information off of this file. And conversely, the vector output one stays very sharp no matter how close we go in. And if we were to load that PDF file into our software, as I mentioned here, import a PDF, we would be able to use this to snap and lay out walls over very accurately. And that's important with where we're sharing our information with collaborators and clients. We might be sharing data very early on a project with people that may be our collaborators, but we're not sure, and we may not want to share all of our information with them. So in that case, it might be in our best interest to share raster-based data of our file. I want to make an important distinction or expand on a discussion that we had with the difference between JPEG files and PNG files. These are both raster-based graphics, so we're actually moving away from the discussion of vector. But I wanted to expand on this idea. We talked about JPEGs as being a compression algorithm to make our files smaller, and we talked about PNG as being another one that kind of retains a bit more sharpness, but it makes a larger file size. File sizes are increasingly less important with faster computers and more memory. But the quality of the line is important for us as architects. And another characteristic about a PNG file that's really important is this ability to have an alpha channel, a channel that has transparency to it. So I've outputted a model view of our building. I've set the background to none. And in this case, none means white in our model space in a JPEG, but when you output a PNG file with none set for the background, we preserve this idea of transparency, that there really is nothing back here. And that's a really powerful way to create imagery, because if we decided now to take that PNG file with the alpha transparency and paste it over a graphic, wherever there was that transparency, our graphic behind it would show through to really nice high levels of detail. So you can see the openings in the building. We can see right through the building. We can see through the railing systems. If we look over here to our tree, we can actually see the background behind the leaves of our tree. So it's very accurately preserving that idea of nothing behind the building and allowing us to integrate whatever graphic we've created, a building or a layout, over a background, and the background could just be a consistent color that we wanted to have our presentation in. So very important for you to I guess, maintain this concept of PNG files having this idea of a transparency layer on it. Kind of a side issue, but something I don't have any other place to fit into right now. This idea of spline tools. We talk about vector graphics. Obviously, we know how to make lines. And I just wanted to introduce, maybe just briefly show you this idea of splines. We'll be covering this in the next module. We'll be actually constructing something. But I wanted to show you that this tool is available to us and to maybe kind of point out a couple of features of it. So I'm going to use detail lines and annotation just to draw a spline. But we could draw splines in roof shapes, in wall shapes, any place that this tool will appear in the tool palette when we start drawing. We can use this tool. And one of the concepts here is really less is more, because these points that we create as we use the tool and click. So I've created 4 points, I believe it is here. Let's see when I highlight it. We've created 4 points, and now we get these what are called control points. So we can modify our shapes in many different ways. So we have an end point and a start point, and then we have all of these to be able to manipulate the shape of the curve. So we get tremendous amounts of control over how we shape. And it takes a while to develop a technique in order to modify these as much as possible. And the caution I would say to you are less points are more. If you try to be very accurate from placing points to define a shape, it'll be very difficult to manipulate and correct that shape going forward. So I'll end this clip, and I think we'll pick up on, let's see what the next slide is here. That's just a little more on, actually this is, before I go to the next section, another problem with Revit and splines is that Revit will not allow you to close the spine. And that is kind of a modeling issue. You almost can't make a free-form surface that is closed because you can't extrude it. we'll discuss more of that as we move into the next project. I'll cut this clip now, and then we'll go and discuss a little bit more about color next.